Hello again, this is Mike Hicks with Business Administration 602. Today we're going to move into the next section, which is production costs. And really it's what we call the theory of the firm. And what I'm going to do here is really give you some graphical explanation of how economists think about business costs and production technology. And it's a very different form of what you see in, say, an operations, an information science, operations management class, or logistics class. But it's this production theory gives us a theory of firms that provide clear information that can be modeled, so it's a benchmark for firms, not a perfect way of capturing production technology that an engineer might use. But what's good about it and what's important about it is it's generalized. And so the models of production that engineers use are firm specific. This is designed to really address issues across the board. And so we'll do this in a couple, 3 snapshots. And I'll just begin by graphing out the way we're going to think about this. Is we're going to start with cost here in dollar terms, right, and quantity. And I'm going to say there's really 3 types of production costs that firms face, an individual firm. The first one is going to be fixed costs, right? And fixed costs, the definition of a fixed cost is that it does not vary across the quantity that's produced. So think about annual insurance or a licensing fee. Those are things that are in fixed production. The cost of a building, for example, if you rent it for a year, that's a fixed cost no matter how much you produce or don't produce. All right. And then there's variable costs. And variable costs, and I'll see if I can get color. I've not been able to produce color on this very well. But variable costs vary with the level of production, and they usually form a function like this, right? Right? And so by that we mean as you start increasing your production, the costs rise faster than quantity, and then there's a period where costs rise more slowly in log terms than quantity, and then there's a rising rate of production. When we get to production technology, you'll see this is called increasing returns, these closer to constant, and then decreasing returns to scale. So there's an area where firms wish to produce, and it's in that center area. All right, and then if you add all 3 of these together, you have fixed cost plus variable cost. You essentially just get a total cost function that takes the same shape as the variable cost, but it has an intercept that's the fixed cost difference, right? So fixed cost plus variable cost equals total cost, all right? A very straightforward way of thinking about this. The difference between fixed and variable cost is a function of the duration of the ownership of that product, okay? And so we would be, excuse me, this gives us a production technology that it doesn't provide us a lot of analytical benefit. It's just a conceptual framework. The analytical benefit comes in the average cost, right? So if we take the cost of production per unit, we get fixed cost. The average fixed cost is fixed cost divided by Q, right? The average variable cost is the variable cost divided by Q, the amount you produce, the average variable cost, and that means that the total cost is equal to, the average total cost is equal to, divided by Q is equal to the ATC, right? Sorry, I'm running off my screen here. And so the average fixed costs plus the average variable cost equal the average total cost. And that's going to look a little bit different, right? So the average costs are going to look different. The average fixed cost starts out very high. The first unit produced, right, is a very high per unit cost, and then it drops quickly and becomes asymptotic, right? So that it shrinks throughout the full universe of production. And by the way, the shape of the fixed cost function gives you the degree to which this product can enjoy scale economies, or getting bigger matters. The average variable cost has a U shape. It drops and then it starts getting higher. It drops throughout this range here to the point where they have an inflection point here, and then there's an inflection point here. That's the point where it rises, shrinks and rises. That's the average variable cost. And then there's the average total cost, which is the sum of the two. And the average total cost, again, sorts to converge on with the average variable cost over time, because the average fixed cost gets so small. Okay, and there's one other element that we haven't talked about yet, and that's the marginal cost. So the marginal cost equals the change in the total cost, what, for each unit. Okay, really in calculus that would be partial TC partial Q. All right, so it's just the change in total cost. So the marginal cost starts out very high. The first unit it drops substantially, and then it starts to rise. And it turns out that the average of the marginal cost is going to be equal to the average variable cost at the minimum point of the average variable cost, if your instructor draws it correctly, and then it rises and is equal to the minimum of the average total cost at its minimum, right? So if I'm drawing these correctly, you're seeing that the marginal cost really affects or intersects the average variable cost of the average total cost at their minimum. And this is important because what it really says, and we'll talk more about this in benefit cost, is that when we get later in we're linking production technology to government, that the marginal cost is the decision tool for managers, not the average cost, not the total cost, but the marginal cost. So I care about marginal cost. So anytime the marginal cost is below an average cost, either average variable or average total cost, then costs are rising but beneath. They're going to be beneath the average variable, average total cost. As at some point when average total cost is beneath marginal cost, then you're seeing the costs rise. So that's an important aspect of marginal cost, is it describes the shape of the average total cost. So if I'm a business manager, I don't know what this shape looks like unless I'm willing to be inefficient and operate in this range, or be inefficient and operate in this range. But what I can tell is that my marginal cost is this. My marginal is the cost of producing one more unit greater than or less than the average of all the units I produce. Because if it's still less to produce that last unit than the average of all the other units that I have together, then I'm beneath my minimum average total cost. If my marginal cost, if the cost of producing my last unit is above my average cost, then it means I'm back in the inefficient overproduction range. So the marginal cost being equal to the average total cost gives us a sense if we're in a range of actual efficient production. And a couple problems with this when you apply it to business. In the real world, empirically, we don't observe these costs like this, right? This is a theoretical construct, this cost function. And it's backed with math. There's math theory about this. The challenge is that in observing this in the real world, what we normally get are, we don't maybe even know what our average variable costs are. We're going to get a range of declining costs, average costs. Then we're going to get a long range of flat average costs. And then we're going to get a range where average costs are rising. So this area to this area will be our minimum average total cost. And our marginal costs, so this is an average total cost, right? The marginal cost will rise to here. They'll be equal to cost are in this range, and then they'll rise more quickly here. And the reason we don't use this in economic classes, theory classes, is that this isn't differentiable. We can't apply calculus to this, right? And this is an easy thing to apply some calculus to. And so, but it's important to think about this, and this varies for every type of production, but they tend to converge by business type. And the best example for this is fast food restaurants, right? So fast food restaurants, you get some that we'll call Q here just being, say, number of meals served. There's a small range that you see very few restaurants in this very small range where they have 3 or 4 workers and a small seating capacity. You just don't see fast food restaurants doing that sort of operation. Then you see a fairly long range of production here, right? And these are constant returns to scale range. And so think about when you go to fast food restaurants from here on out, some of them are going to be very, a little bit smaller than others, but you never see a fast food restaurant with 80 people working in it or 3 people working in it. It's usually, 6 or 8 to about 18. So that range is, typically employment, range is in that, 8 to 16 or employees at a fast food restaurant. I know we're in COVID and that, as I draw this graphic, changes that calculus a little bit, but generally we observe this level of production across the world. So fast food restaurants in Germany, in the Netherlands, in Japan, in Seattle, in Atlanta, in Chicago, in Connersville, Indiana, or Lexington, Virginia, all look the same way. And that's because firms learn from each other. They're trying to do the same thing. They're trying to keep labor costs down. And so places where labor costs are really low, maybe they'll have 16 people on shift. Places where they're really high, they'll have 8 people on shift. There's a certain amount that they can sustain and operate effectively, and they stay within that range. Sit-down restaurants are much the same thing, particularly the chains, right? So the number of people who sit in an Applebee's or an O'Charlie's or a Ruby Tuesdays tend to all be very similar operations, throughout the country. And so that size, that scale of operation tends to result from firms learning from one another and trying to optimize the same sorts of production processes. So this is the cost side of production. And you really need to go back to the text and read this, because I've covered a lot of material. First, I just talk about the cost structure of a business, right? Then I talk about the analytical component. The cost structure is the fixed cost plus variable cost equals total cost. Then I went through the average cost structure, where average fixed cost plus average variable cost equals average total cost. And I introduced the analytical element of the marginal cost curve. And that's what we're going to care about a lot down the future. So you have to understand this and this and this. Okay, and then I demonstrated what this really looks like in the real world, which is this less elegant treatment that's you cannot use calculus with, but it describes the real world very well. And so, this production technology is a good way to think about everything from classroom instruction to fast food restaurants to airliners and ships. And it gives you a sense of how firms think about the cost of producing goods or services. Thank you.